All right, so so what are we talking about? Okay, so think. It's good to think. What? Okay, yeah, so we're going to do that. Like, what's the bigger topic that we're... So we're talking about, so we did distributed loads, and then we're going into how to calculate the stresses due to the shear forces and bending moments. We know how to calculate the stresses due to the tensions. And before we can calculate the stresses due to the bending moment, we have to figure out, how to calculate this moment of inertia. Okay, so I talked about the aerial moment of inertia.
What exactly does aerial mean?
So a moment is a, so if you have a, so this integral is called the first moment of x. And you're integrating with respect to x, so that would be like, I don't know what you would call that, a linear moment or something, If you do this, that's the first aerial moment because you're integrating with respect to the area. If you do it like this, then that's a mass moment. And then the second moment is like this, And so what we have is like, I'm going to erase this in case that's wrong. But yes, something like that is definitely true.
I thought aerial.
Yes.
Aerial, like not
Oh, yeah.
aerial.
Okay, right. So it's the moment with respect to the area, whereas the moment of inertia that you use in dynamics is integrated with respect to the mass. So that's a mass moment of inertia.
That makes sense.
And there were two things that I said to remember about these. The first is that it follows the parallel axis theorem. And so if you're trying to calculate the moment of inertia about some axis A, then that's equal to the moment of inertia about the neutral axis plus the area times the distance squared, where this d is the distance from the neutral axis to A. And then the second thing to remember about the aerial moment of inertia is that you can add moments of inertia of component pieces to get the moment of inertia of a complicated shape. So you can calculate it as a sum of moments of inertia of component pieces. Okay, so let's do an example problem where we do an I-beam. So this is like if you had this beam and you had loads applied to different parts of it, and you're trying to calculate the stresses in different parts of this I-beam. before you can do that, you have to calculate the areal moment of inertia. So a cross section looks like this. And let's say that the thickness everywhere is 1 centimeter, so 0.01 meters. Let's say the height is, well, let's say that inner height is let's say that's 0.5 meters. And let's say that the width is 0.5. Okay, so we have a few things we have to decide here. If we're doing this as a beam calculation, how is the coordinate system normally oriented here? How do you orient this coordinate system? The y-axis is up. So there's y. What direction is x? In this, it's towards us. Yeah, over here, it's down the long axis of the beam. And then the z-axis is this way. And so in this view, the y-axis is there, the z-axis is there. And what about the origin? I did it sort of right in the middle. How do we choose where the origin of this coordinate system goes? It goes on the neutral axis. So how do we choose where the neutral axis goes? Yeah, the neutral axis is at the centroid and horizontal. So this is the neutral axis. So the z-axis points along the neutral axis. And let's break this rectangle up into 3 rectangles. I'll call this one 1, this one 2, and this one 3. And I'm going to calculate the moment of inertia of each of these component rectangles. Okay, so the formula for moment of inertia, the moment of inertia about the neutral axis is the width times the height cubed over 12, was it? 12. Okay. So that is 0.5 is the width. What's the height of rectangle 1? Yep, it's 1 centimeter. We're just looking at that one rectangle. And that's cubed and then divided by 12. And I think you end up with, oh yeah, could you calculate that? 4.17 times 10 to the minus 5 meters to the 4th. Okay, so is that what we need to add to the moments of inertia of the other 2 in order to get this whole thing? There's one more step we have to do. We calculated, this was about the neutral axis of, no. Not this again. What is it? Okay.